Hello, everyone. Good morning, good afternoon, good evening. Welcome to the HiveMQ webinar on future-proofing IoT environment with multi-cloud approach. My name is Jayshree Hegde, and I will be helping with moderating today's session. Join me in welcoming our speakers for today, Peter Youngton, Director of Solutions Engineering at HiveMQ, and Nasser Qureshi, Senior Product Marketing Manager at HiveMQ. Very warm welcome to you, Peter and Nasser. Before we begin the session, I did like to share a few housekeeping pointers. The session is being recorded, and we will share the recording in a follow-up email later this week. If you have any questions, please use the Q&A pod at the bottom of your screen. We will answer as many questions as possible during the Q&A session. We will also run a short poll during the session. I request you all to cast your votes. Also, stay tuned with us till the end of the session. Why? Because Peter will be showing you all a hands-on demonstration on how to connect an MQTT to various cloud in just a few minutes. So stay tuned with us. And now, without further ado, I will hand it over to Nasser. Welcome, everyone.
Thank you, Jayshree. Hi, everyone. Thank you for joining us. I'd like to introduce you to our agenda for today's webinar. First, we'll be talking about the multi-cloud approach and exploring it in an IoT environment. I'll also be talking about the factors to consider when evaluating an MQTT data ingestion solution for your multi-cloud environment. Towards the end, we'll talk about how HiveMQ is the certain central nervous system that brings everything together, connecting MQTT, the cloud, these hyperscalers, and data and your IoT devices. And in the end, we have a special treat for you in which you can see it all in action with Peter. Next slide. All right, great. So let's get started. So I'd like you to consider a real-world scenario in which there's a car-sharing platform that provides 24/7 on-demand rent-to-drive services throughout Europe, right? So what they do is they have different parking lots throughout the cities that they operate in, and the whole experience is completely touchless. There's no human involvement. It's all digital on your phone through your app. And they use MQTT to connect their vehicles to the cloud, and they use the cloud to process data for their, for trip management. They can use that data to, assess driver behavior and fuel management. So they use all of that, right? And then also use it for predictive maintenance to see if there's something wrong with the car. They can make sure that they do the maintenance so that their fleet is always available to their customers, right? But also imagine if they only had one vendor and the whole tech stack was built on one. Now, what do you think could go wrong, Jayshree? So what are the potential risks of relying on one vendor? One, they'll have a single point of failure. So when if anything goes wrong on with that vendor, there's a service disruption or anything, their business is disrupted. When their business is disrupted, Jayshree, next, please. They have downtime and they have revenue loss, which again is very costly for them, and they don't want that because they have a complete digital experience. So technology and availability, is very important to them. A lack of flexibility because they are, locked with one vendor is also a problem, because what happens if there is they need to shift their workload for some reason, or there's an availability issue again, right? So and we'll talk more about vendor lock-in, but that's another issue with compliance and security risks, right? So there might be some compliance and security risks when if that cloud provider is faces an attack, or if there's some compliance issues from that cloud provider that could impact this company as well. Next. To solve that and to address these issues, you can address these issues using the multi-cloud approach, right? So what is the multi-cloud approach? It is a strategy to utilize multiple clouds to optimize your workload performance, your cost efficiency, and resource availability, right? So you want to make sure that at least these three areas are optimized, and the multi-cloud can help you do that. According to this chart, if you can see over here from a report from Flexera, 87% of the companies that were surveyed already use the multi-cloud, and within that, 72% used a hybrid setup, 13% used multiple public clouds, and 2% used multiple private clouds. But as you can see, the multi-cloud is already a very popular approach in enterprises these days. And why? Well, one, you can take advantage of unique strengths of each cloud provider. So if one cloud provider is better at data analytics, you can use that. If the other cloud provider is better at machine learning, you can use that, right? So it gives you that variety, that flexibility to do that. Then you can mitigate the risks of vendor lock-in. We'll talk more about that later in the presentation. But it also enables you to port your workload. So distributing it, making sure that it's taking advantage of edge computing, making sure your customers have a better experience because it's quick. There's quicker load time. There's less bandwidth needed, and then finally disaster recovery. Right. So if there's something wrong or something goes wrong with a data center of one cloud provider, you can still make sure that your data is safe and services are still maintained, and you can provide those services to your customers. Next. So what does the multi-cloud approach look in IoT environments, right? So what you care about most is building solid, IoT applications. And for that, you need the best in class, technologies, and you need that flexibility. So what you need to do is you want to diversify your tech stack to reduce risks, like we just talked about. You need flexibility to adapt to changes that are happening in your business environment really quickly. So you need that flexibility, and to get that flexibility, you need to make sure that you have as many options as are available. Then for operational and cost efficiency, again, you need to adopt the multi-cloud environment approach so that you can take advantages of cost optimization. We'll talk more about that a little later. So for IoT applications, especially, one size fits all doesn't work anymore because the environment is getting more competitive. The technology are getting more complex. So, for example, a company might, for instance, want to use AWS for storage and database because of costs, or they might think that these AWS services are better in this function, right? Google Cloud might be used for machine learning with their cloud AI platform, or Azure could be used for edge computing and analytics, right? So it all depends on the business itself and the whole situation that they're in. But it's important to realize that with the multi-cloud, you get that flexibility. Next, Rashmi. Now, we're talking about a couple of big advantages of the multi-cloud approach. One is avoiding vendor lock-in. Now, this is a major risk, and a lot of companies were faced recently when a major cloud provider decided to deprecate one of its key technologies, and they were sort of stuck in time. And because of that, they had to scramble and look for different solutions, right? So you don't want to be in that situation again. You want to make sure that you are as diversified as possible so that you are not dependent on a single vendor's technology stack, right? And by avoiding vendor lock-in, again, you reduce your single points of failure. You improve your system reliability and availability, and make sure that you're always there for your customers. You can make sure that you're flexible and you can switch between providers when the need occurs. You can also make sure that you have the best solutions at your disposal when you want to use them. And then when there is a new cutting edge technology available, you don't want to be hanging in there and salivating that I can't use this new technology. that this new cloud provider has come up with because I'm not engaged with them and I don't have them in my system, right? So you don't want to be in that position. You want to be as diversified and have as many options available. Next. Another key advantage of the multi-cloud approach is cost optimization. As you can see in the chart on the left, of the people surveyed in this report by Flexera, optimizing for cloud spend is the biggest initiative that they're looking for in 2023, right? So cost is a major issue that enterprises are looking to tackle. So by using the multi-cloud approach, they can leverage competitive pricing by utilizing multiple cloud providers. So if one cloud provider is better, has better pricing on storage, they can use that. If another is better on using AI and machine learning services, you can use that, right? So you have that flexibility. Then if you want to negotiate better deals, you can do that again because you have more power. Because you can always switch your workloads between cloud providers, so you'll have more leverage in negotiations. Resource allocation is another important factor where you can save your costs by using the most effective cloud provider where you can save your costs. So if storage is cheaper in AWS, for example, you can use that. And if machine learning is better in Google Cloud, and the processing is cheaper, egress costs, etc., you have that flexibility to do that. And then you can also minimize your data transfer and bandwidth costs, where you can locate your workloads closer to your end users, and that reduces the amount of data that is flowing through the internet, and then it can reduce your bandwidth costs as well. So that's another advantage. Next. We've talked about the advantages, but I wanted to touch on some of the challenges of the multi-cloud approach as well, right? So one of the biggest challenge can be managing compatibility and cloud spend between multiple cloud providers, because you're using these massive companies and you're negotiating with them. It can be a little complex, and you might need more resources to manage the compatibility and the spend and track that spend. So that is one challenge of the multi-cloud approach. Integration is another challenge that can occur. It's not always so easy to integrate technologies with these multi-cloud providers and IoT devices. So you might need more resources to that have that skill and expertise to integrate these technologies. Then compatibility and operability is also another challenge when custom solutions that enterprise might create to integrate these technologies. When these custom solutions are used, it might be complex to operate and make them compatible with all the technologies. Governance is also a challenge, especially complying with data privacy and security regulations, which have come up in the past few years, like the GDPR and CPRA. And managing permissions across the multi-cloud is another, a complex challenge that you might face in the multi-cloud approach. But there are solutions for that. We can answer them if you guys need more information on that. Next. Now, finally, I wanted to talk about. So we've already talked about, the multi-cloud approach, the advantages, challenges. But when you're looking for, an MQTT solution that, is for your IoT environment, you should be able to at least consider these, these factors. And we believe that these factors are really important for you to understand. Scalability is highly important. Of course, IoT devices can reach in the hundreds of millions. So you want to have a solution that can handle data at scale. You want a secure solution that is secure, right? So it has the ability to secure communication between your devices and make sure that any sensitive data is not accessible by any malicious third parties. You want to make sure that's reliable, because IoT devices and the whole environment for your business is really important to enable bidirectional data transmission between your devices, the cloud, and the broker itself. So you want to make sure that that broker is really reliable. Integration as well. You want to make sure that you're not locked in with one broker, but the broker is open sourced and can connect to other brokers and platforms as well. So you want to make sure that the MQTT broker that you use is compatible with them and can enable the multi-cloud and connect with other brokers as well, right? So that's really important for flexibility as well. And then support and documentation, you might not realize this, but this is a really important factor as well, that the broker that you use has very good support and complete documentation, so that you have that that expertise at your disposal should you need it at any time. Next, Jayashree. Now, we've talked about the multi-cloud approach. MQTT is the de facto and the best protocol for IoT devices, and this is where HiveMQ comes in. So HiveMQ is the central nervous system of your IoT environment, right? So what it does is it connects IoT devices via MQTT to the cloud, and has a whole suite of solutions for you, where you can, with its broker and combined with its extensions, you can connect with all of these cloud providers, and it enables bi-directional data transmission at enterprise scale, hundreds of millions of devices. So HiveMQ enables everything that we've already talked about and more. So it is the solution that for you that enables the multi-cloud and helps you take advantage of all the factors that we just talked about. Next. So this is it from my side. I hope you guys understood the importance of the multi-cloud, the advantages, the challenges, and how HiveMQ can help. Now you can see it all in action with Peter. I'll hand it off to Jayashree first, and then we'll move on. Thank you, everyone.
Thanks so much, Nasir. So before we move on to the live demo, we will run a quick poll. I will run it about for a minute, and I'll stop sharing. Peter, you can start sharing your screen. So I request all the attendees to cast your votes. Thank you so much. I will run it for about a minute.
Perfect. Thanks, everyone. Thanks for the handover. Let me just get my stuff started here.
The polls are up. I request you all to participate. All right. Let me end the polls. Thank you so much, everyone, for participating. So, Peter, stage is all yours.
Thanks, and welcome, everyone. Let me quickly get rid of this picture. Welcome, Nasir, or thanks, Nasir, for doing this introduction. I think this is really spot on, and what I want to do now is I want to give you some examples how this can be set up with HiveMQ. So first, what you can see here, this is part of what Nasir has already shown to you. What I want to emphasize on the left-hand side here, we really have a very modular access and distribution layer, which means on the left-hand side, you have all this connectivity, and Nasir mentioned earlier, there has been some services that are discontinued by big vendors. And when you talk to these people that have to find an alternative solution for them now, they are really under very high pressure, because now they have embedded something in these devices, and when they don't have over-the-air updates, then it's really a challenge for them. And the big benefit here with this approach, when you use MQTT, you have an open standard, you have an open protocol, and of course we are super happy to provide the services for you, but of course as it's a standard, you could choose a different solution as well once you're set on the standard. And then what you can do, and I've created this here in this dotted box, you can create this to the cloud. For example, you can run this on any cloud that you want. But of course, as an alternative, you can even run this self-hosted. And the first part of my demo will be a self-hosted MQTT broker just running on my machine. And later on, we will go to the, let's say, advanced level where I show you how this can be deployed on Kubernetes. And that can be any Kubernetes distribution. Today, I pick Google, but could be AWS, could be Azure, could be IBM, could be whatever you want. And this is what I want to show to you. So the left-hand side is provided by HiveMQ with all this flexibility. And then we have all these connectors to the right-hand side to the enterprise systems or cloud or hyperscaler systems. Just wanted to mention this again. On the left-hand side here, you can see a mobile app and you can see a car. So all this connectivity can be handled just by HiveMQ. So you can run it somewhere, you can run it in the cloud, and we are providing the service. So, and in case you don't like the cloud provider that you're currently using, of course, on the backend side, you can interface with any cloud provider that you want, but you can be sure that this is still being handled by HiveMQ. And I think this is a very big and very important point. What I've done for this local demo, or for the demo that I'm going to show you, I've just downloaded and set up a local HiveMQ broker to my machine that has a normal evaluation license for all the extensions. So if you want, you can try this yourself. If you want, reach out to us, then we can help you set this up. And what it is doing, or what it has an AWS, so Amazon Kinesis extension. I will show you how you can interface with Kinesis. It has a Google Cloud PubSub extension and a Kafka extension, and all of them are running in parallel. And then again, I have a very basic setup. I have just some MQTT topics. This is a topic called starting with topic and then in. This is mapped to the clouds. And then when you want to publish something from the cloud side back to the device, you can use the topic out on these cloud providers. And I'm just mapping this to MQTT topics. So this as a quick overview. And now let's jump into medias res immediately. I hope you can see my code now, my IDE, and let me show you how this can be set up. Here, I've downloaded HiveMQ version 4.14, and I can expand here this extensions folder. Can you quickly confirm that you can see my my IDE? Okay, works well. Good. And what you can see, this is a platform release. I've just downloaded this, and what you can see, these are the commercial extensions that we are providing. And here, what I've done, I've just enabled the AWS extension, I've enabled the Google Cloud PubSub extension and the Kafka extension. The other extensions, for example, in this case here, the enterprise security extension is disabled. When there's this file in it, and by default, it's in almost all the extensions, then they won't run. And now let's take a quick look at the AWS Kinesis extension. This is the folder, and this folder contains the AWS Kinesis configuration. When I quickly open this, then you can see the XML file. So this is the configuration that needs to be done to have specific mappings. And here, first of all, you can see you have an AWS credential profile that contains your login credentials, so that in this case, this broker can connect to AWS. And in AWS, I've set it up to have specific permissions. And then you have mappings. You have mappings from MQTT to Kinesis, and you can have mappings back from AWS Kinesis to MQTT. And again, excuse for that, but that is pretty straightforward. What I did here is all the topics or all the messages that are coming into a specific MQTT topic, in this case, based on this topic in, they are just processed and they are mapped to this Kinesis stream, which is called webinar demo. And this is a very straightforward mapping. All the messages are just collected from the broker and they are pushed to a Kinesis stream. If you want to do something more sophisticated, then you don't just need mappings here. You can do transformations here using transformers. And by the way, I wanted to show this to you. Some people say, why do you use XML? The big benefit of XML is we have these XSD files here. And these XSD files, they allow you to do code completion and to do verification that all of these settings are correct. So you saw when I had this section in there without any content, it was underlined in a red way and said, okay, this is not a real configuration, so please go ahead and fix this. So I've just, specified this configuration, and that is more or less what it does. And when I start this broker now, I just go to the bin directory and I run the broker. Then you can see that it's starting up. Here you get some information, what it is doing, that it starts all of these extensions and so on. And then what I can do, let me quickly open another terminal. So, and in this terminal, I can publish information. So you can use, if you want, MQTT CLI from HiveMQ. So you can say, okay, I have an MQTT topic. I have a specific topic. The topic is called topic in, and I want to publish a message. And this is a test from MQTT CLI. And when I do not specify a host name, it will take my local machine. And in this case, it's my local broker. I just hit return. Sorry, what it does, of course, I need to tell that I want to publish something. So there we go. And now the message has been published and is processed. Now I can go back to my browser. I can go to AWS Kinesis. The only thing that I've set up here, I've created Kinesis data streams. I've created one stream. This is the webinar demo here. And I've just allowed, with these AWS credentials, I've allowed the permission to write to this webinar demo Kinesis data stream. And when I go to data viewer, you can see I have two shards. Shards are a way to load balance to the cloud. Again, HiveMQ is highly scalable, but you need to make sure that, of course, the cloud provider, the cloud providers have load balancing as well. Then I can say, okay, give me all the records. Currently, it does not have a record because it was already, published and provided. And when I send this message again here to publish on this topic in, then I can go here to the next record, and then you can see test from MQTT CLI. What you have seen, I just downloaded HiveMQ. I've just enabled with only a few commands this extension, and all the data is being pushed now from MQTT towards or through HiveMQ, currently working on my machine, but to the cloud. And that is pretty straightforward. Now, what I can do, and we hear this question many times, people will say, but when I change this configuration, can I modify it? And of course, you can modify this configuration at runtime. What HiveMQ will do, it will check if this configuration is correct. If the configuration is correct, it will automatically apply it, and it will specify in this config archive here folder, it will create a backup so that you can see what previous versions have run, and it will just activate this new version. And of course, you can use the other way around. That would work as well. In this case, when I publish to a Kinesis stream called webinar demo, it would just take this information and would publish it to topic/out, and you can see that this is running. This is Kinesis. And now, again, it's pretty straightforward. When I want to do the same, for example, for for Google Cloud PubSub, we have the same. Here we have this XML file. Here's the configuration. For Google, the permissions are stored in slightly different way, but the rest is pretty straightforward and it's the same. So whatever I publish to topic in will be published to PubSub topic called demo topic. And then we can see that this is working. So let me quickly change my screen. Again, this is one of the cloud providers. For HiveMQ, we are what is beneficial for us, we are super cloud agnostic. So previous demos that I did, I just used EKS, so the Elastic Kubernetes Service from AWS. Today I use Google, I can use AKS as well, so the Azure Kubernetes Service. And what we do, we just interface with these backend systems. So here you can see we have a topic in, we can take a look at now all the for this specific topic. In Google Cloud PubSub, you need to create a subscription when you want to see messages that have been published. And then you can see here, these are the messages. I can pull them, and then you can see after a moment that these messages are being pushed here. And then you can see, okay, we have received these messages. Now, of course, when I go to my CLI here all the time, that is pretty boring because I do not want to publish data all the time. Another big thing that HiveMQ provides is a tool, and the tool is called HiveMQ Swarm. So here under this tools folder, and this is part of all the distributions of HiveMQ, you can see HiveMQ Swarm. Then you can see a scenario folder, and in this scenario folder, there's a scenario XML file. And what you can do here, you can specify what kind of information should be published by HiveMQ Swarm. Here I've just specified a broker that it should connect to. You can specify how many clients you want to have. In this case, again, excuse it, it's running on my machine, pretty boring. This is only one client that I provide. Usually when we work with prospects, then we have, 10, 50,000, 100,000, 1 million, 5 million. You can choose how many clients you want to simulate. Then you can specify how many topics you want to have. And here you can work with wildcards as well. In this case, I just say, okay, create one topic. The topic is called topic/in. And then you can specify life cycle stages here. I can say, okay, first stage is connect to the broker. Then I tell this in the second stage, please publish with this connection on a topic group 1, which is my topic in topic. Please specify, send 10 messages, create random payload on these messages, because currently I don't have any specific data that I want to publish. And I can say, please publish a payload of 1,000 characters. So it's publishing 1,000 characters. After this is done, it will just disconnect. And when I want to run this swarm scenario, I can just go to HiveMQ, to tools, then I go to swarm, then I go to the bin folder, and here we have HiveMQ swarm. I just execute this. So now you see it has immediately done this. So now this is over. And now when I go back here to my topics, I can just pull this information. And again, I just said, create 10 messages and create a random payload. So this is what you can do. Because many people say, we are just about to start our journey. We want to make sure that this works, and this works for the next year. Currently, we have 50,000 connections. Next year, we plan to have 1 million. The year after next year, 5 million. And with Swarm, you can simulate this. Having said this, this is now the Google Cloud PubSub extension. And of course, there's another one. We have a connection to Kafka as well. Today, I decided I wanted to search, or I wanted to use a Confluent Cloud. Again, I've just logged in with our Confluent colleagues to just have an evaluation version of a Confluent Cloud, but that can be anything. That can be a self-hosted environment. That can be Apache Kafka somewhere. That can be Elastic Kafka services, or MSK, sorry, managed Kafka services on AWS. That can be anything. And Kafka is pretty well known. And here I've just created these 2 topics. And when I subscribe to this one topic here, then you can see here, I can see the messages that I'm showing. And currently, because I just subscribed to this Confluent Cloud, to the topic in, and when I go back, and now let me quickly, where are we? There we are. Let me quickly execute the swarm scenario again. So now it connects, now it publishes 10 messages, and now it disconnected. And then when I go back to my Confluent user interface, there we go. You see, here's all the data immediately. So it's really end to end. In this case, of course, I have not enabled authentication and so on. So we have lots of capabilities for secure authentication and authorization. You can, of course, have this TLS encrypted up to version TLS 1.3. So you have everything that HiveMQ is offering out of the box, and you can just reuse it. And this shows you, let me quickly, for completeness, show you the setup for the Kafka extension. So here in this Kafka extension, you see this is the configuration. Again, we have clusters that we are connecting to. And then here you have these topics. You can see that the Kafka topic here took an MQTT filter. It specified topic in, and it's publishing this on topic in as a Kafka topic. Of course, here you can have transformers as well. For example, you can say, I want to subscribe to a Kafka topic out, for example, and then I want to use certain data of my payload. And based on this data of my payload, I want to publish this to a specific MQTT topic. Let's say I have an update command in Kafka, or sorry, update topic in Kafka. So I'm publishing all the updates into this update topic in Kafka. And based on the payload of these Kafka messages, I want to map this to specific MQTT topics. Of course, you can do this as well, and then have an integration in this. The important point is here, you can just take HiveMQ and you can move it to any environment that you want to. So this here is the configuration of these extensions. And now I want to quickly move to another example, how you can deploy this. So let's go back here to the slides. This was the local setup. And now what we did, or what I did, I just deployed this to the cloud. And you can deploy it to any cloud of your choice. We've seen in Nasir's slides, there were, I think, the big three cloud providers, but that can be any cloud provider. What we are doing, we are providing a Helm chart, and this Helm chart for Kubernetes is providing a HiveMQ operator. And what the operator does, in a nutshell, you just specify tell the operator, I want to have a HiveMQ cluster of a certain size in a specific setup, and this operator will just deploy it for you. So here, in general, you have two options. First one is you can just create a values file like this, would look like this. And then you just, or the people that run the Kubernetes environment for you, these people would just execute this one command. And this is the command that you execute. And once you execute this command with this values file, what it will do, it will automatically specify in HiveMQ cluster, let's say this way, it will create a 5-node HiveMQ cluster with 4 CPUs, each cluster node on 4 gig of RAM, and the log level will be debug. Of course, that can be more comprehensive, this file. You can specify the Kafka configuration, the pub/sub configuration, and so on can be part of this as well. But with more or less one command, you can deploy this on one cloud of your choice. If you say, we don't like this file here, we don't like this approach, you can even specify for example, in this case, the node count as a parameter to this command. And then you don't even need to specify this file. You can just deploy this with running a single command. What it will do, it will deploy HiveMQ on your Kubernetes environment. And this is a user interface that some of you or many of you probably know when you're working with Kubernetes. Here I've just used OpenLens, or you can use Lens. Then you can see I've deployed HiveMQ here on that environment. This is a GKE environment. Again, could be any Kubernetes environment. You can see what is deployed on this environment. And you can see these here, these 3 are the HiveMQ cluster nodes. So they are there, and they are processing all the data. What I can do now is, let me quickly open another screen. I can show you what is called the HiveMQ control center. Let me quickly one second. Okay. So what I can do, one moment, there we go. Okay. What I can do is the control center looks like this. Now let me go back here. Let's go to my machine first. This is the control center. And this is the user interface. So this is where you get all the information, how HiveMQ looks like. You can see how many clients are connected. So currently there are no clients connected. The number of cluster nodes, again, this is on my machine. I can see that we have the Kafka extension enabled here and so on, and you can see all the client details. And now when we go back to Lens for a moment, many people say, but it's a challenge when we do not use the hyperscalers or the cloud providers MQTT implementation, then it's really a lot of work. And let me now quickly show you how you can scale up such a deployment. So here you can see these are the 2 HiveMQ cluster nodes. On the left-hand side, you see all kinds of configurations. Then you see here, we have a custom resource definition. The custom resource definition specifies a HiveMQ cluster. You can see the node size of this HiveMQ cluster is 3 nodes running in this software version. I just deployed it 27 minutes ago, last minute, but it's highly automated, so I just did it. And now when you say, okay, we are expecting more load, we want to connect, or we want to process more messages, or we have more clients, what you can do, you can just edit this custom resource definition. Then you say, okay, here I go to node count, and here you see the node count was 3. And now I say, I want, for example, I want to have 4 HiveMQ nodes. You just click on save and close, and now I need to be fast. Here it says 4 nodes. And when I go back to my ports, you can already see, okay, this is the new port. So what happened, the operator has automatically deployed a new HiveMQ port that is currently starting up. So all these preconditions are done. Now it's starting to join this cluster. That takes a short moment. And then you have a 4-node cluster. So this argument that people say, but we need to run this and it's a lot of work that we need to do, I think it's only partially valid. And the same is true, for example, when we want to make a software upgrade. So you just tell the operator, I want to go from version 4.14 to version 4.15 or whatever. Then the operator will recognize I need to make a software upgrade. It will start a new node. The new node with the new software version will join the cluster. Once the new node has joined the cluster, an old node will be decommissioned. And then an additional new node will be started and so on. And this is, so it's super convenient to provide this this management. Let me quickly try to log in again. Again, it's always the challenge once you have demos. I tried it previously. What I want to show to you is I want to show you the HiveMQ user interface. So this is now, again, my cloud deployment here. Data is being simulated with Swarm. We are running this on HiveMQ. We have extensions to all these cloud providers. And what I can do now, I can click on this link. That will kick me to HiveMQ. This is now this Kubernetes deployed instance. I just log in. And then what you can see here, you see the dashboard. Here I was just running some example load using HiveMQ Swarm distributed across three cluster nodes, because at this point in time, it still were 3 cluster nodes, right? And now we have added a new one. And here on the right-hand side, you can see when exactly I've upscaled the cluster. So this user interface almost looks identical to the one that I had running on my local machine. And this is important for us. We want you to have the same experience everywhere. If it's running in your data center, on a cloud, on AWS, on Azure, on Google, wherever. And then here you can see these are the data. This is the data of all the cluster nodes. And now, you know, HiveMQ Control Center is just to take a look, to analyze what clients do we have and so on. And because we are deployed on Kubernetes, we are automatically integrating in all your Kubernetes toolset. So the more or less default standard for Kubernetes is that people run Prometheus for metrics. And of course, we automatically integrate into Prometheus. And on top of Prometheus, many prospects are using Grafana to visualize this. And here on the bottom, you can see this is the HiveMQ dashboard. When I click on this, I just log into Grafana, and there we go. You can see some metrics of the HiveMQ cluster. And here we had to pick a selection of metrics. These are, I don't know, something like 20, 30 metrics. What HiveMQ does, HiveMQ exposes, each of these cluster nodes exposes more than 1,500 metrics. So again, it's not a big black box for you. When you want to see what is going on with HiveMQ, you can see all this data. So you can see, do we reach a certain bottleneck? Do I need to scale out? Do I need to optimize something? And what we do is we even provide distributed tracing. So which means if, Nasir has mentioned this example, you have a car sharing service and you want your users to have a good experience. And if somebody clicks on unlock car and this takes 30 seconds, then you should know this. And this information is exposed by HiveMQ, and you can drill down to a specific request and you can see what is going on. So you can use this access and distribution layer from HiveMQ. And on the right-hand side, so on this cloud backend, you can use whatever you want. You can use best of breed, you can move this and so on. So you have the full flexibility. This, again, I think regarding security and so on, all these other things that HiveMQ is providing, we can maybe make a follow-up session, another webinar where we can demonstrate this. I just want to give you a quick overview how easy it is to be set up and how easy you can scale this in your environment. And this is, you know, my part currently. And with this, I want to hand over back to Jayashri.
Thank you so much, Peter. This was really awesome. I'm sure our attendees would have got a lot of insights on how powerful HiveMQ is. Thank you so much. Request all attendees to give us a thumbs up if you guys liked our demo. And I will also share a link in the chat quickly. If you need more information, you can get in touch with us. Thank you so much. I think we are right on time to take on the Q&A sessions. I do see there are lots and lots of interesting questions coming in. Thank you so much for the feedback as well. You have been sharing with us. It's really awesome. And let me start off or kick off with the Q&A with one of the questions we have in the Q&A pod. The question is, MQTT is a classic IoT or embedded PubSub protocol, but why using it for enterprise-grade solutions? Where are there any other PubSub solutions? Peter?
Absolutely. So great. Last week, for example, we were at KubeCon in Amsterdam, and a lot of great discussions happened there. And what we're seeing is many people use their favorite protocols for microservices communication and so on, which is absolutely fine. And we are not here to replace them. But what we recognize that MQTT still seems to be a niche in some areas, and the MQTT protocol has a lot of benefits over other protocols. And when we talk to people that already use MQTT in their IoT use cases, many of them are considering, okay, I have now an event sourcing use case. Why don't I use MQTT? And when they're familiar with this protocol, they see what benefits it brings. Again, it's not on us to say you should replace this and this in your backend. For those people that work with the protocol, there's a lot of benefits that it has over some other protocols. But of course, this highly depends on the use case. And as people probably know HiveMQ, we are super passionate about this protocol. If you have a specific request, feel free to reach out to us. We are happy to discuss.
And thank you, Peter. And I'd also like to add in our example for connected cars and with the rent-a-car service that we talked about, in connected cars, MQTT is very popular, and a lot of high-tech vendors or car manufacturers are using MQTT to connect their cars.
And just as Nazir mentioned this, I have one example from a prospect that I talked to last time. They said, back in the days, they said, we have created our own IoT protocol. You can do this. They speak over raw TCP sockets, and this is fine for us. And they said, and now we want to migrate to MQTT. And what you can do is, I've just shown you the extensions that HiveMQ provides. These are our commercial extensions. You can extend these extensions, so there's an SDK for this. But what you can do, you can create your own extensions. For example, the prospect that we talked to, the person said, but can I integrate my legacy applications? And they can. So what they do, they use MQTT for the next generation solution, and the things that they currently have in place, we can just integrate this using a custom extension, and then you can process the data as well. So we're super flexible with this.
Thanks a ton, Peter. Thank you so much, Nasir. There was one question around the demo you did, Peter. I think you already covered it. Did you use HiveMQ Community Edition for the demo, or all these connectors are only available with paid version?
So I did not use Community Edition. Community Edition is our open source version. Again, the foundation of HiveMQ is the same, and everybody that just wants to start with this, of course, can do this. And we have an extension SDK for Community Edition as well. What I'm using here, these extensions, they are commercial extensions, and they are working with our commercial product. So just for some people that may be interested in this, the Community Edition, the main difference is Community Edition does not have the control center. That is a big difference. And Community Edition doesn't have the commercial extensions, and Community Edition doesn't have clustering. So when you want to try something of these features, reach out to us so that we can set up a session and that we can provide you with more details about this. What you can do for people that just want to test it, when you use the commercial edition of HiveMQ, it is you can try it. It is limited to 25 connections. And the extensions are limited, I think, to 5 hours. After 5 hours, the extensions stop working, and then you would need to restart it. Again, when you want to give it a try, just a test drive, feel free to do this. And again, we would be glad if you reach out to us to talk about next steps then.
Awesome. Thank you so much, Peter. There is one more question around the same demo you did. So Alexander is asking, did you use any Visual Code, VS Code plugins for the demo, or is this just Java JDK enabled configuration?
Mm-hmm. So I just used the extension for XML so that you can use this XML linting and XML code verification. This is more or less standard. You can just use it. And then I just used the terminal interface. So nothing special. For VS Code, you can use VS Code, but you can use any other editor as well that allows the integration of XSD files to XML files. And again, even this is not crucial, it's not mandatory. If you want to use some other editor, whatever, and you want to edit XML files, you can do it with this as well. The only downside would be, so what HiveMQ does before it starts or before it applies a new configuration version, it checks that this version is valid. So you cannot really break anything in HiveMQ. It could just be that you try to import an XML configuration and the broker does not accept it. This is why I just use it for convenience.
Thanks, Peter. There is one interesting question. Wen is asking, can you please introduce the current commercial application of MQTT in the Internet of Vehicles?
For that, I would need more details.
Okay,
so,
all right.
Yeah, it's so what we can do, I think Nasir already mentioned, for connected car, this is more or less the de facto standard because MQTT has so many benefits. It's a super lightweight protocol. I think this is important to mention. Then what is important specifically for this connected car use case is that the broker is aware of the connection. With many other protocols, you don't really know if the client is still there. And when, for example, you have a car that is connected to a broker, the broker knows if the car is still there or not. Giving you one example, you have this integration. Again, it's to this concrete example, you have an integration into AWS Kinesis. You're pushing data out of Kinesis to HiveMQ as an MQTT broker. And now for some reason, the car is disconnected. Maybe it's in a tunnel. The MQTT broker knows about the connection state. So the broker knows, okay, the car is not there anymore, but the car, when it registered, said it wants to have a persistent session. So it said, when I'm disconnected, I will come back. So now the broker is able to queue all of these messages. And once, let's say the tunnel has ended, or I'm located in Germany, so in rural areas of Germany where we don't have internet yet. So when the car connects again, then the broker will know the car is back and will deliver all of these queued messages. That is important. And some other stuff that is pretty specific to MQTT. You can specify the quality of service. For example, so when you have a car and you want to do predictive maintenance and you're pushing metrics from this car every second, you can tell with a quality of service level of 0, for example, that the client and the broker, they are allowed to drop messages. Let's say if I'm providing values for temperature every second and I need to drop one message because of an overload or flaky connection or something, then because after 1 second, I will send another temperature value, and that would be sufficient for me. You can indicate this by a quality of service of 0. But stuff, for example, when there, let's say, an accident happened, and you want to make sure that this information is transmitted and delivered over the MQTT broker, you can say this is quality of service 1. Then the client and the broker will make sure that this information is at least delivered once. So just a few examples, there are plenty more. Maybe that person, if you're interested, just reach out to us, then we can talk about more details.
Awesome. Thank you so much, Peter. There's one more question in the Q&A pod. Do you see any difference of HiveMQ broker performance when it is hosted on different providers? Are there any hidden problems related with certain providers?
Yeah. So I think it's difficult to answer this in a generic way. There are no generic issues that we have with cloud providers. What is important is we at HiveMQ, compared to some other vendors, for us, it's really about reliability. And when we are receiving a message, and for example, this quality of service 1 example, when you send us a message to say, this is quality of service 1, I want to have this message being delivered. Then we are persisting this message. And we're persisting this to disk, because if a broker node would crash in exactly this moment and we would have this information only in memory, then it would be gone. So we persisted to disk. And there it's important, depends on the use case, that you have enough IOPS. So regarding the performance of the hard disk, we are persisting this information too. I think this is crucial. And to make sure that you're on the right side and that all of this is working, use HiveMQ Swarm. With this, you can verify it. We don't like guessing, and so probably don't you. So just verify with Swarm. I have, 5 million connections. I have this message rate and so on. I want to have these messages being delivered. This is why we built HiveMQ Swarm. So verify this. Another option that is sometimes a challenge when we're talking about massive connectivity, like hundreds of thousands, millions of connections. This is not a standard use case even for hyperscalers. So you need to make sure that the load balancers that are in place and so on, that they are able to handle this amount of connections. For HiveMQ, it's not a big deal, but sometimes the services that are in front of HiveMQ, you need to make sure that they are sized the right way. But there's no generic problem with any of the cloud providers or with hyperscalers.
Thanks, Peter. I just wanted to add to the person who asked the question that the solutions that we create at HiveMQ, the mission that we have is we want to make sure that you are flexible, right? So all of our solutions are built for reliability and flexibility. So we make sure that all the extensions that we're building are as reliable as our broker, and you have the flexibility to connect to any cloud provider that you want and take advantage of their services. So that's part of our ethos, and decoupling or preventing vendor lock-in is the whole point of having all of these different options for you, so that you have that flexibility and you can manage your workload balances as you see fit.
Thanks, Nasser. Thanks, Peter. There is one more interesting question from Frank in Q&A. Can you also use MQTT locally, like production lines, and not connect to the cloud, but a local cloud? What can be the performance?
Absolutely. And this is specifically for smart manufacturing, a great use case, because when you have machines, when you have huge machines and they have PLCs, and the PLCs, are running, motors or something, doing some motion and so on. These PLCs, today's PLCs, are enabled for MQTT. So you can connect these PLCs, for example, to a local broker. And this depends a little bit, again, on the use case. We have customers and prospects that are using an MQTT broker for a single machine, because they say we have so many PLCs that are managing this machine. And the MQTT broker is used to connect all the different PLCs, and for example, then forward this information into SCADA systems or to HMI or to something else. So you can do this. Or what you can do, you can create federations of brokers. For example, you can have such a scenario. You have a machine, all these PLCs connecting to one local MQTT broker. This broker is told what information should stay local to the machine and what information is going, for example, or is forwarded to the production line. And from the production line, you have an MQTT broker, and that is forwarded to the factory broker, and that is forwarded to the enterprise broker, and so on. And you can specify, this is, again, a great benefit of MQTT and this flexible topic structure. You can define in a very detailed way what information stays on what level and what information is bridged and forwarded to the enterprise level. So that, for example, when you want to have, QA information that is on the enterprise level, whereas all these, bulk data that you don't need on the enterprise level is only kept on this line. So we see this a lot. And again, the big benefit of the usage of HiveMQ, you can deploy it everywhere. This can be even air-gapped. We have customers that say, we love MQTT. We do not want to have any connectivity to the outside world. Then you can even provide it air-gapped.
Awesome. Thank you so much, Peter. I think we can cover one last question. I know there are lots and lots of questions to be answered. You can either reach out to us to community forum, or I have also added in a link where you can reach out to us via a form. One last question. Can it be possible to use external cloud storage? Is it possible to use external cloud storage to store persistent information about MQTT message?
Mm-hmm. The answer is yes. So we have two options. First option, when we as HiveMQ, we persist information, then we are usually writing this to in a clustered way. So in a cluster, we always use a replication factor of 2, which means we have one message, and this is always distributed to at least one other cluster node. And there we store it into file system. So this is the case. And of course, you can do this, and we persist it there. What you can do if you want to persist it somewhere else, for example, again, you just saw Kafka, Apache Kafka, Confluent Kafka. And another option is that you use MQTT, so HiveMQ as a transport layer. You use the Kafka extension to push this to Apache Kafka, because Apache Kafka, for example, you can query data that is stored in Apache Kafka. This is not a concept that an MQTT broker has. So depends on the use case, but we persist it to storage. We always keep at least 2 copies of the data in case, one node or one storage system is lost. We still have the data, and but you can use it or forward this to other systems as well.
Thank you so much, Peter. We are at the top of the hour, and will not be able to cover all the questions, but feel free to reach out to us via form, via community forum. We are here to help the MQTT community and the IoT community, and we have lots of resources on our website. We recently released a 2023 MQTT Buyer's Guide, which will give you a lot of information on MQTT brokers and whether it would fit your IoT use case. So it's available on our website. Feel free to download it, and we will be sharing the recording of this webinar via follow-up email very soon, probably later this week. We will have all these information and the links in the follow-up email. So stay tuned with us, and take care. Thank you so much, Peter and Nasir, and thanks to all attendees for joining us today.
Thanks, Terry.
Bye-bye.
Thanks, everyone. Bye-bye.